All right, so we're going to be doing some more with graphs of polynomials, talking about two things today, increasing and decreasing, and domain and range. So we're going to start with increasing and decreasing. This means if I were to take my finger and trace along the graph, if my finger is going up, that's increasing. If it's going down, it's decreasing. If it's flat, it's neither. So when you do increasing, decreasing, you always go from left to right. And we're going to use something that's probably new to you. This is interval notation. So what we're going to do is we're going to have, and in this like a coordinate. It's going to look like a coordinate, like a point, but it's not actually going to be a point. Instead, the first number is where it starts increasing. So it starts, and we're going to do the x. So it's the starting x, comma, the end x. So where it starts increasing to where it stops increasing. So we're going to write the x value where it begins, the x value where it ends. If it's an arrow, so if we don't have an actual point to find where it starts, if the arrow is on the left side, so if you start at an arrow, it's going to be negative infinity. If it's on the right side, we put positive infinity.
How are you drawing?
It's a sideways 8. Some people turn their paper sideways every time, but I don't know. I do them a lot. So what's very, very, very important is that with increasing and decreasing, we're only writing the x values. So what I want you to do right now is we're going to take all of these, there's 3 points, and we're going to write those coordinates in. So what is that coordinate? Negative 3, 3. Good. What about this next one? 2, 3. And then the last one, 3, 6. Very good. So here's where your highlighters are going to come in. We're going to pick one color for your increasing and one color for your decreasing. So going from left to right, if I start down here, am I going to be increasing or decreasing? Increasing. Now this next section is not doing either, so I'm not going to highlight it either color. And then when I get here, what do I do? Increase. And then after that, I decrease. Good. So I'm going to have 2 intervals of increasing and 1 interval of decreasing. So let's look at this first increasing interval. Where does it start?
Like an arrow?
Well, that's an arrow. So that it actually goes on forever. So if I have an arrow, what am I supposed to put down? Negative infinity. If it starts at an arrow, it's negative infinity. Because I really could not, this goes on forever. Down, down, down forever. So I really can't pick a starting point. Okay, but it goes up here. Where does it end?
Negative 3.
What am I only supposed to write? The x. So just the negative 3. So it increases from negative forever up to negative 3. That's one section where it's increasing. Then we have another section. Where does that one start? It starts at 2. The x value is 2. And then it ends at the x value of 3. And then this last one I have is decreasing. So where does it start decreasing? 3. And where does it stop? It doesn't. So because it's on the ending side, the right side, it's going to be a positive infinity. Even though, here's where people get confused, even though the arrow is pointing down, increasing, decreasing is x. So we're not thinking up or down, we're thinking left or right. And it's pointing to the right. So that's why it's positive infinity, because on the right side of the x-axis are positive numbers. The left side are negative numbers. So let's do some examples with polynomials. I do want you to change this, instead of a -9, to a +1. So you'll need your calculator. Whenever we graph, we always have to find the max and min values, because those are the points that we use in these intervals. So go to your y equals and type in x squared plus 6x plus 1, and then go to the graph. And I only have one turning point. It's a minimum, which is really the vertex of this parabola, which we did a whole unit on. But use trace. And I'm going to say that is a minimum. You can write -3.03, but really, more accurately, it is just -3, -8. And I know that because of the formula that we use to get the vertex would make it -3, -8. Because remember, using the trace button isn't perfect. It just gets really close. And so then when I plot that, -3, -8, I always like to go ahead and put the coordinate on the graph. That'll help you when you're trying to do your increasing and decreasing. And then I personally like to go to the table and find a few other points to plot just to make it more precise. Second graph. It's not really necessary for finding these intervals, but I find it makes it look better. But the one point that really matters is this minimum. So using your highlighters, I want you to highlight where it's increasing and where it's decreasing. And try to use the same colors that you used the last time. Yes. Did you change it to +1? Change it to +1.
Would it all be increasing?
No, you don't. You think about if you were to put your finger on the graph. Don't think about the way the arrows, because it doesn't go like this. If you put your finger on the graph and you trace it, my finger's going down right here. So this is decreasing. And then right here is increasing. So, and it doesn't really matter which ones you write first, increasing or decreasing. I tend to always write increasing first. So where is it increasing? Where does it start? Where does it start increasing?
Negative 3 negative 8.
What's the x value?
Negative 3.
-3, comma, and where does it stop? Increasing, it goes on forever. On the right side would be positive infinity. So if it stops at an arrow, it's positive infinity. Okay, because that arrow's on the right side. What about decreasing? Where does it start? You can't really pick one, and that the arrow is to the left. It's on the left side of my interval, so that would be negative infinity. And where does it stop? -3. Your intervals should always go least to greatest, and so -3 is smaller. If you want to think infinity, think 1 million. -3 to 1 million, that's least to greatest. -1 million would come before -3. Okay. Any questions? Okay. All right, let's go to number 2. -x cubed minus x squared plus x minus 2. And I go to the graph. Hit trace. So I have a minimum at -1.06, -2.99. And then my maximum, the highest point, is 0.30, -1.82. This is kind of what the graph looks like. And we're going to highlight where it's increasing and where it's decreasing. I have one interval where it's increasing. So where does it start increasing? Negative 1.06, and it stops at where does it stop increasing at? 0.30. So this increasing starts at this point, starts at the minimum and ends at the maximum. And we only put the x values. Any questions on that? Now the decreasing, there's two. So this first one, where does it start? We would put negative infinity because there's an arrow where we would start. And then I go down, and I'm down at this minimum. What is the x value at that minimum? Negative 1.06. Good. And then my other decreasing starts at that 0.3. And where does it stop? Infinity. Questions? Yes. We're getting ready to use this. So here's where you're going to need your popsicle sticks. We talked about domain and range earlier this year. Does anybody remember anything? Does anybody remember what domain is?
An X.
Domain is a list of all the x values. And we did it before when we had, actually we did interval notation with this. Like we had the first one where it started and where it stopped. So that's kind of what we're going to be doing today. If there's an arrow on the left, what do you think I'm going to put? Negative infinity. If there's an arrow on the right, I put positive infinity. So with domain and range, we are looking at the graph as a whole. I want to know what's on the far left, comma, the far right. So the far left to the far right. And your popsicle sticks are going to help you kind of narrow that down and see where that is. Okay. The range is a list of all of the y values. Y values go from bottom to top. So what do you think you would put if there's an arrow at the bottom? Negative infinity. What about if there's an arrow at the top? Positive infinity. Good. So let's take your popsicle sticks and let's put them on the left and right until we hit part of the graph. Okay, so I'm going to use my purple highlighter to show where I would be on the far left. So here and here. That's the left and the right sides. What do I hit on the left? I hit the arrow on the left. Because technically this graph, even though it looks like it's just going straight down, it's actually tilted a little bit to the left. And it's going left forever. So we're going to put negative infinity. What about to the right? What does it hit? It hits an arrow. So So if it's on the right side, we put positive infinity. So what this means is that my graph goes forever and ever left, and it goes forever and ever to the right. That includes all of the x's. It's gonna, if I went to my table, every x value, if I looked at every point I could possibly get, I would have every x value in the world. Another way we can write that is this symbol that represents all real numbers. It's like an R, but it's got two lines, like that. That's a symbol that means all real numbers. So if you ever have negative infinity to positive infinity, meaning we start as left as I can ever imagine and I go as right as I can ever imagine, that's all real numbers. For what we do in this unit, that will always be your domain. You are always going to have an arrow on the left. You're always going to have an arrow on the right. Just for this unit. That's not every time, all the time, just this unit. Now let's look at the range. So turn your things over. Notice that B stands for bottom. So if it's an arrow on the bottom, it's negative infinity. If it's an arrow on the top, it's positive infinity. I just kind of put that there to remind you. So put these popsicle sticks until they hit a piece of your graph. I hit it there, and I hit it there. So what is on the bottom of your graph? An arrow. So we start with negative infinity. I'm going to draw that in. What's on the top? An arrow. So positive infinity. Or you could have wrote the all real number symbol. Now your range is not always going to be this. It will be this about half of the time. So sometimes we have an arrow on the bottom and the top and the left and the right. In that case, domain and range are both all real numbers. Let's look at an example that's different. So number 5. So domain, if I move my popsicle sticks until I hit the graph, right there, what did I actually hit?
Arrow.
I hit arrows on both sides. So my domain, if I were to draw some vertical lines here to show where those popsicle sticks would be, my domain is negative infinity to positive infinity. Now the top and the bottom, my range, are looking a little different. So for the range, we start at the bottom. What's at the bottom? There's arrows at the bottom. So we always put negative infinity when there's arrows. But the top, do I have an arrow at the top? No, I have a point. Now range is talking about your y values. So we have to put down the y value of that point, which is what? 1.3. What this means, if I have this equation and I type this equation in, I would never see a y value bigger than 1.3. Okay, if I looked at the table, there would never be a y bigger than that. So we're going to do some examples where we're going to just kind of get everything. We're going to practice all of it. So we've got an equation. Let's put that in y equals. And then I'm going to go to the graph, and I'm going to start by getting my max and min so that I can get my graph drawn.
You want to use both maximums?
Yes. So I have graphed both maximums, the minimum, and sketched in the whole graph. So next thing we're asked to do is find the end behavior. And where's the arrow pointing on the left side? The arrow is pointing down, so it falls to the left. And then on the right, there's an arrow. So falls. Both arrows are pointing down. So don't get confused with falls and rises and you're increasing and decreasing. They don't always correspond with each other. Okay. The end behavior is specifically talking about the direction the arrows are pointing. When you're doing increasing and decreasing, that's thinking about tracing it with your finger. So if I trace it, I would be increasing, and then I switch to decreasing, and then I switch to increasing, and then back to decreasing. Now remember, you're increasing and decreasing, you always use your X's. Domain, you use your X's. Range, you use your Y's. So for the increasing intervals, I've got this first one. Where does it start? Negative infinity. And it stops where? Negative 1.06. Good. And then from there, I'm decreasing. So I'm still at negative 1.06, and I go down just a little bit to the 0, the x value of 0. And then I switch back. I'm still at the 0, but I'm increasing to 1.82. And then I switch back to decreasing. I'm still at the 1.82, and I decrease to infinity forever. Are there any questions on that? Okay. Now domain. Think about domain. So if I drew in my vertical lines, what do I hit on both sides? I hit arrows. So I've got negative infinity to positive infinity. Or you could put the real number symbol. For my range, is my range going to be all real numbers? No, because I don't have arrows on both the top and the bottom. I do have arrows on the bottom, so my range does start at negative infinity. But where does it stop? .31. Very good. It stops at the y value, the highest y, because your range are your y's. So lowest y, I can't get a lowest, but I can get a highest. I want you to graph, go ahead and graph number 7. All right, I had a maximum at 1.974. You might have also put 2.4. And minimum at 0, 0. What about the end behavior? What does it do to the left? Rises to the left. What about to the right? Falls to the right. And then I go decrease, increase, decrease. So we start decreasing. I start at an arrow. So from negative infinity to this point down here, and that point has an x value of 0. So my first interval of decreasing is negative infinity to 0. And then I'm still here at 0, but that's where I start increasing from 0 to 1.97. And then I switch and I decrease from 1.97 to infinity. Very good. Then if you think about the domain and range, domain on my left side, what do I have? An arrow. On my right side, what do I have? An arrow, as you will for every one of these problems. Negative infinity to positive infinity. And then the range, I have an arrow on the bottom and an arrow on the top. So the range is also negative infinity to positive infinity. I want you to do number 8. Do that one by yourself. And then tomorrow we'll do number 9 back together to review, and then you'll do some more practice. You're going to have to do a lot of this just to get good at it. So you should see the graph. It rises left, rises right. Increasing, there's two intervals from negative 1.82 to 0 and from 1.06 to infinity. And it decreases from negative infinity to negative 1.82 and also from 0 to 1.06. Domain is all real numbers, negative infinity to infinity. And range, we hadn't had this one yet, but the bottom is where we start. We started on a point. So we started at negative 3.31 and ended at infinity for the range.